Kinetic energy is defined as the energy an object has due to its motion. The formula to calculate kinetic energy \KE is where \IV is the velocity of the object in meters per second. This equation tells us that kinetic energy is directly proportional to both the mass of the object and the square of its velocity. In the International System of Units, SI, the standard unit for kinetic energy is the joule, J. 1 joule is equivalent to 1 kilogram multiplied by meter squared divided by second squared. The work energy theorem states that the net work done by the forces on an object equals the change in its kinetic energy. The work energy theorem states that the net work done by the forces on an object equals the change in its kinetic energy. Conservation of kinetic energy. In a closed system, the total energy remains constant. This means that while kinetic energy can be transferred or transformed, it is conserved in the absence of external forces. For example, in an idealized situation of an elastic collision, the total kinetic energy of the system remains the same before and after the collision. Examples and applications. Everyday examples. A car driving down the highway has kinetic energy. The faster it goes, the more kinetic energy it has. If you double the speed of the car, its kinetic energy increases by a factor of 4. Because velocity is squared in the kinetic energy formula. A thrown baseball has kinetic energy proportional to its mass and speed. A heavier ball or a faster throw will result in more kinetic energy. 2. Safety measures. Understanding kinetic energy helps in designing safety features, like airbags and crumple zones, which are meant to absorb and dissipate kinetic energy in crashes, reducing injury. 3. Environmental impact. Kinetic energy is also considered in renewable energy systems, such as wind turbines, where kinetic energy of wind is converted into electrical energy. In summary, kinetic energy is a foundational concept in physics that describes the energy an object possesses. It plays a critical role in various fields, from everyday experiences to advanced scientific research. By understanding and applying the principles of kinetic energy, we can better analyze and influence the physical world around us. Thank you for your attention. If you have any questions or need further clarification on kinetic energy or its applications, feel free to ask.